Hi friends, in this session we will going to do the data analysis for CRD design. It's having 2 replications and 23 treatments, and this is for equal number of replications or observations or plots. You can see here in this first table you will get the character name, or you can call it a parameter name. For example, plant weight, need to give unit, that is gram. Okay, you need to give that name over here. Below that you will get the treatment. You can see here you will get the 23 treatments with respective of R1, R2, that you called as replication or observation per treatment or observation per plot or number of plots, like that you will get here. You can give the input here. You just put manually like these values, or if you have data in Excel, you just go to your data, just copy your data, come to our design, select first cell, then right click. You can select here the paste option as a values, just click on it. You'll get all the values are here. Okay, and this is fully automatic design, so just you need to change this value as per your character or parameter. So keep in mind one thing, don't change any formula from this Excel sheet, otherwise you will get a wrong result. So you just need to modify or change your data, which is highlighted with the help of red color. If you want to buy this type of Excel sheet, then definitely you will get my WhatsApp number link in the description of this video. Then definitely you contact me, then definitely I will give you this type of Excel sheet. It's a paid Excel sheet. Please remember, if you want, then definitely ask me on WhatsApp, or if you have any query regarding your research data analysis, then definitely ask me in the comment box of this video. So definitely I will address your problem in the comment box. Okay, so I will going to explain what exactly you will get from this Excel sheet. If you want to add anything or any point in this Excel sheet, then definitely ask me, then definitely I will going to add if you need anything more than this. But as per my knowledge, it's sufficient for your research or your thesis, so that once you look all the things, I will explain little bit in this session. If you have any query, then definitely ask me in the comment box. You can see here, this column you will get the treatment total, and this column you will get the treatment average, or you can call it mean. Then this cell you will get the grand total value. You can see here you will get GT value, that is grand total value. Okay, very important, you will get the ANOVA table, that is the analysis of variance table. In that you can see source of variation, in that you will get the treatments, error and total. The next column you will get the degrees of freedom. You can remember the formula t minus 1 for the treatment, n minus t for the error, and n minus 1 for the total. You will get the degrees of freedom. Then you will get the sum of square. This is the calculation part. We are summing the all this total for the treatments. Okay, then dividing by the replications and subtracting the correction factor. So you will get the sum of square. Then mean sum of square, you will get here the mean sum of square, the formula for sum of square divided by degrees of freedom. This is the formula for mean sum of square. Then f calculated, you will get the f calculated. It's a simple formula also for f calculated, mean sum of square divided by error sum of square, error mean sum of square, sorry, error mean sum of square. Okay, So then you will get the yep table for 5%, then 1%. Okay, then you will get the significance. If you want probable values, then definitely ask me, I'll add here if you want. Okay, you can see here the significance, whether your treatments are significant or non-significant. You will get here. Here is ns means non-significant. If here is sig, that is significant. Okay, below that table you will get the correction factor, which is used for the sum of square calculation. Then CV, you remember CV always in percentage. Okay, you can see here it's a too high CV. Remember, for lab experiment CV should be less than 5%. For field experiment CV should be greater than 5% and less than 20%. Okay, less than or equal, you can put equal as well. So you remember this thing, and you will get the CD for the 5% and CD for 1%. You can see here, if your treatments are non-significant, then don't go for the analysis of CD and post hoc analysis. You remember, after this you need to do the post hoc analysis. Okay, if you want any information about the post hoc analysis, then definitely ask me in the comment box. I will definitely give the information regarding the how to do the post hoc analysis. Okay, so if treatments are non-significant, then not need to calculate these values as well. Okay, it means CD values. Just put in your edges NA. Okay, if your treatments are significant, then you need to calculate CD value as well as the post hoc analysis. Okay, you can see here you will get the final thesis table. In that you will get the treatments. If you want to put the treatment name here, so you can put name here. That name will reflect over here. For example, I'll put the HCN, just for example. Okay, you can see here. Then you just copy this table and use for the your thesis. And then below you will get the graphical data representation. Just you need to change the name as per your character which you took for the analysis. That is plant weight in gram. Just you give the name here. Access title you give name here the treatments, and here you just give name the plant weight in gram. If any query regarding this, then definitely ask me in the comment box, or my WhatsApp number in the description box. Then definitely contact me. If any query regarding your research, then also you can ask me. Okay, thank you so much for watching.